In this video, we'll move the Taylor series expansion from cosine to negative sine. We begin with the dataset of cosine. So, array formula, cosine of the x values 0 to 6, and the negative cosine. Array formula, cosine of the x values 0 to 6, and we factor in the negative sine. And we'll chart this. Insert chart. And we use scatter chart. Row 1 is header. Show the trend line, series, trend line, polynomial to the 6th degree. For the label, use the equation. For the legend, position at the bottom. And here's our trend line. And polynomial of cosine and negative cosine. Next, we continue with the expansion, which is the summation of a times x minus theta raised to the power 2n, where theta is k pi. So k times pi. And the value of k is from 0 to 1. So data validation, list of items, 0 to 1. So we can start from 0 for Maclaurin series and then continue with 0.2 and so on. And the value of n is from 0 to infinity. And the expansion coefficient a is negative 1 raised to the power n over factorial 2n. So this array formula, minus 1 raised to the power n. That's the numerator, divided by denominator. The denominator is factorial 2n. Factorial 2 times n. And now we can complete the expansion. So array formula, series sum of the x values raised to the power, or that is x minus theta. So x minus theta raised to the power 2n. 2n starts from 0, incremented by 2. And the coefficient will be this range. And enter. Their values are the same. But we're missing the trend line of the negative cosine. So edit chart, customize series, trend line, the type polynomial to degree 6. For the label, use the equation. Now we have the label, the equation. Next, we calculate the polynomial regression coefficients. This regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. This is transpose 0 to 6. And the elements of the matrix, array formula of the x values raised to the power 0 to 6. Then enter. Now we can calculate the polynomial regression coefficient using LINEST. So LINEST, data y, that's for the cosine, and data x for the expansion. LINEST, data y, and data x. And finally, the negative cosine. LINEST, data y, and data x. And let's compare, starting with x to the 0. Coefficient of x to the 0, 1, 1, negative 1. So 1, 1, negative 1. Coefficient of x minus 0.0555 plus 0.0555. Coefficient of x squared minus 0.354 plus 0.354. Coefficient of x cubed negative 0.147 plus 0.147. Coefficient of x to the fourth 0.117. This is 0.117 rounded up, and negative 0.117. X to the fifth minus 0.0201 minus 0.0201. This is rounded off as 0.0201, and is 0.0201. Coefficient of x to the sixth 1.07 times 10 to the minus 3, negative 1.07 times 10 to the minus 3. Suppose we change k to 0.2. This time, our theta is 0.628, meaning our expansion moves to the right 0.628 radians. We move this to, change this to 0.4, it moves a little farther. It's now 1.256 radians away from cosine. A little farther, 0.6, it's now 1.885 radians away from cosine. It's approaching negative cosine. 0.8, now it's getting closer to negative cosine, and it is now 0.2513 radians from cosine. And finally, 1. These values are the same, and their polynomial regression coefficients are the same. They are now collinear. So our expansion approximates negative cosine. If we set this at 0, our expansion approximates cosine, and the red and the blue lines are collinear. This completes the use of the Linus polynomial regression, Taylor Maclaurin series, factorial, and series sum function to generate the expansion of cosine and move it to negative cosine.